recording? Okay, it's recording. Okay, so so this is the final workshop for GameStart, and for today's workshop, we'll be going through how you can integrate Git for version control, as well as to collaborate with other developers in Unity, as well as to build your game and then publish it or put it on the itch.io website. So without further ado, let's get started. We'll start with Git or GitHub integration. And so Git is a version control system. In fact, the most popular version control system right now. It has about a 95% market share in version control. But what is a version control system? So a version control system is a system that allows you to save backups of your code base. For example, say you're working on the game and the game is already functional. So it can be played and it can, it has these kinds of features. Your players can jump, it can move around, right? So say from this point onwards, you want to keep this working version of the game, but you still want to continue developing new features or optimizing some of the logic in your games to make it faster or to make it look more elegant, right? So in this process, we never know when your changes will break the current code base. It's something that we cannot expect, something that we cannot predict. So what if at this point of time, you would be able to save a backup of this working code base such that in the future, if you did any changes that would break your game, you can easily retrieve that backup and then start from that backup again. It sounds like this would be a very convenient tool to have. And this is exactly what a version control system is. So it allows you to save backups or snapshots of your code base at any given time that you put it to be saved. And you will be able to quickly revert back, roll back to this previous version if you need to. It keeps track of all of your change history such that you have a very sophisticated list of what have changed from your previous, from whatever time it was. So you will be able to look up that change history. But certain version control system also comes with different types of different types of tools. There are some that gives you very powerful control over your code base, and Git is one of it. So it also allows you to Git also allows you to separate development and production code bases. So for example, if this current code base is already working, you can use Git to create a completely separate isolated environment to start your development, and it will not impact the working copy that you have stored. This is what we call branching, and I'll go through branching very quickly later. And there are many more features from Git, but those are generally a bit advanced, so I will not be going through in this workshop. So a bit of background is that Git is created by Linus Torvalds, which many would probably know him as the creator of Linux. And Git is also maintained by Git, so it's kind of a circular dependency there. What about GitHub? So GitHub is a remote hosting service for Git repositories. So I mentioned that you would be able to save your code both locally and remotely with Git. And GitHub is the free hosting service that allows you to save your code base to a remote location, to their servers. So with the server access, you will be able to fetch code from other people or just store it as a backup. So if anything happens, you still have a working copy on the cloud that you will be able to fetch it easily. For example, what if your PC was infected by malware and then you had to wipe the entire disk, your previous progress are all gone, but at least you have a remote repository that you can clone it completely back down, and then you can just use it as is. Aside from that, if other people also has access, you give them permissions to edit your code base on GitHub, they will also be able to make changes to it and push to the same repo. They will be able to give updates to that same repository. So essentially, it enables you to collaborate with other people for your code base. And some portfolio-based users, you can showcase your product to other people. It might be useful if you're trying to apply for a job. And if you're an advanced user of Git or an advanced software engineer, you can also collaborate and commit to open source projects. So GitHub is also the largest open source website that you can find. There are millions of open source projects on GitHub that is actively maintained by a lot of developers. So if you're interested, you will be able to look it up. So with all that said, we will just be going through a very simple Git session today. And if you're a CS student, there should be a more in-depth look into Git and the workflows of using Git when you take CS 203. So let's get started here. First of all, you need to set up your Git repository. So if you've been following around the workshop, you would have known that this is still not a Git repository because you haven't set it up properly. So if you already have an existing code base and you want to set it up as a Git repository, you'll first need a Git client. And for simplicity's sake, I'll be using GitHub Desktop for this showcase. But GitHub Desktop is not my preferred Git client because it lacks quite a bit of feature. But if this is your first time using Git, I do recommend getting started with GitHub Desktop because it has very minimal features, but it gets the job done. So you'll be able to get familiar with it. So to get started, you need to open your GitHub Desktop. And of course, you also need to be logged into a GitHub account to use GitHub Desktop. So I hope you have done so. If you have done so, you'll be able to, give me a moment, right-click any of your asset folder and select Show in Explorer. Notice that this brings you to the assets folder of your entire project. So a Git repository starts with a root folder, and this will be a root folder. This is where your Git repository would be in. It will contain, your Git repository will then contain all of these files in this root folder. So you want to go up a level and another level to get to this GameStart folder or whatever you named your project as. Then you just need to go to GitHub Desktop and then you just drag and drop the folder in. So this will tell you that this directory does not appear to be a Git repository. And this is indeed the case. So what you can do is to create a repository here. If you don't drag and drop in, any Git repository that you add or create locally would need to be, cannot have spaces in their name. But as you can see, because I have spaces in my name, I wouldn't be able to do that. But if I drag and drop it, I'll be able to click on Create Repository, which will give me the name with dashes in it. This is completely fine. Okay. Then you can give it any description. We don't care about the description. Okay. You don't really need to initialize this repository with a README because this is just a game, is not something that you want to really be open sourced. Now, very important is you need to go to git ignore, select the drop down, and then go all the way down and click on Unity. Without this Unity git ignore, you'll be committing a lot of the unnecessary files to your Git repository, which takes up a lot of time to upload, change, and for other people to download and collaborate. So make sure you always initialize this repository with a git ignore and use the default Unity git ignore. This is good enough. Then the license, we don't need it, just leave it as none. And then you can just click create repository and this pop-up will show up. This repository uses Git LFS. So Git LFS is a plugin of Git that allows you to store large files. And as you have probably already noticed that assets file in Unity are quite big. For example, your images, your sprites, they are a few megabytes. You compare it to any script, which is a few kilobytes in size, that's like 1,000 times larger. So for these kinds of files, you would generally use LFS. So I will just click on initialize Git LFS here. And now you have your Git repository correctly initialized. So now in this GitHub desktop GUI, you'll see that it allows you to select repositories. This is for other Git repositories that you have in your computer, on your computer, that you have added to GitHub desktop. You probably don't need this today. Then you have a branch. So these are the branches that is available in this repository. We'll be going through this later to show you what branching can do. Then there's publish, which allows you to publish this repository to GitHub. I won't be doing this now. We'll be doing this later. Yes. There's the changes, which shows you the changed files that is currently not the same as the current commit that you're on. So the commit thing, it feels like a backup. Yeah. And in the history, it shows you what commits you have. So right now we only have the initial commit, which is the first copy of the repository. So then you see that there's like hundreds of files here. This is normal. This is how an empty Unity repository looks like. All right, there's a few hundred files, and these are all added in the first commit, and we just leave it there. So what can you do with Git then? So I said that you will be able to store backups of your code base, and this is what we call incremental changes. You will be able to make changes to your code base incrementally, so that every single time you would still have a working code base that is not far off what changes you have right now. And this is great because if anything broke, you can just restore the previous progress and then start from scratch again, but you won't be losing a lot of progress. You'll just be losing probably a little bit. So let's get this started. So for example, now I'll go back to our scripts here, and then I'll click into the enemy movement class. So if you've come last week and you followed through our tutorials last week, you would have noticed that now in the game, when the enemy dies, it spawns a gold coin. But you should have also noticed that, say if the enemy is not dead, right? Say if the enemy is not dead, sorry. And if I just stop the game here, there's a coin spawned there. There's a coin that spawned there. So the reason for this is as shown in this error message here. It says some objects were not cleaned when closing the scene. You spawn new game objects from on destroyed. So the reason for this is that when you close a game scene, the game object is also destroyed. So we can't just put it in on destroyed and then spawn a new coin. This will cause your scene to not be properly cleaned up and may cause some issues in your future development. So let's try to fix this bug. Okay. So let's try to fix this bug. And instead of putting this in on destroy, I'll define a new public method, and I'm just going to call this death. Okay, I just call it death. And then I'll just move all of this logic into death. And then remove the on destroy method. Okay. So now that I've moved all of this into death, I still need a way for the player when killed, the enemy when killed will still be able to spawn a coin. So in the player interaction, I'll go over to this destroy. And before I destroy the game object here, I'll do a collision dot transform dot parent dot get component enemy movement dot death. So this allows me to get this component enemy movement and then call the death method. So once the enemy dies, once I stepped on the enemy head, it calls the death method and it destroys this game object. We can try to simplify, we can try to make this cleaner a bit more by moving the destroy logic into enemy movement like this. So all I'm doing here is that I tell the enemy to die, and then the enemy is going to instantiate a coin and then destroy itself. So far, are we clear? Okay, good. So now that this is the case, let's try to see if this is working properly, just to test things out. Okay, so I probably need to increase my move speed here. Here. Move speed. Let's change this to 5. Yep, so the coin is spawned properly. And if I leave the game now, you'll see that there is no leftover coin from the enemy. Right, so this is good. This is exactly how we want this to be. So now, when we go back to our GitHub desktop GUI, you will notice that now there are 2 files in changes, which you should notice that these 2 files are the same as the 2 files that we modified just now. It's enemy movement and player interaction. Right? So how do we read these changes? Basically, the red lines indicate that this line was deleted. And this tells you which line it is. So this was line 33 in the enemy movement file. So if I go to the enemy movement file and line 33, it's here. So it was originally private void on destroy. This was deleted. But on line 33, I also added a new line indicated by the green line here called public void death. This means 33 has been deleted, but a new line has been added also at line 33, which is we replace the line with public void death. Then it also tells you that on line 37, a new line has been added, which is destroy game object, which is exactly the changes that we did just now. The same thing also in player interaction. It says that we have deleted destroy and then also added this new collision transform parent get component, enemy movement, death. So this is how you read the changes from Git. Red line signifies that it has been deleted, and green line specifies that it has been added. And these are the two line numbers for these changes. So now that I've done that, let's commit this change so I can keep this code base that is free of this bug as a backup. So how do I do this? You click on this summary on the bottom left, and you type in any message that signifies what this change is. So this change is we fixed the bug where the scene wasn't cleaned up properly. So we will be able to put a descriptive name such as fix bug, fix enemy move, enemy die bug, for example. So this doesn't need to be very explicit. And with this, you will also be able to add a description if you need this commit to sound a bit more descriptive, because fix enemy die bug, what bug, right? Usually you want to keep the summary very short, and then you add any kind of relevant details in description. So for example, you can say fix a bug where gold coin will spawn if the scene is exited in the editor. Something like this. Okay. So now that you have written all the required details, a description is not really required, it's optional. If the changes is easy, then you don't really need a description. You can just click on commit to main. Okay. So now you click commit to main. Let's do a change. Give me a second. Okay, that's because I forgot to click on this plus. Okay, now you click on commit to main. You'll notice that here, these are the changes. And now it's committed. So what can we do with this, right? Is as you go into history, you see that now we have two commits. The first one is what we made when we initialized this repository, and the second one is what we changed. So say I don't want this bug fix anymore. I want to revert it back to its original state for whatever reason. You'll be able to right click and select checkout commit. What this does is going to keep all these backups in place, but you will be able to go back to where it was. And it tells you that it creates a detached hit. This means that any changes you make to this code base from this point onwards will not be able to be committed to the code base because you're not on any branch. You're not on any streamlined flow here. But say you don't want to just check out. Say you don't want this change anymore. What you can do is right click here, right click the previous one, and click on reset to commit. As I click on this, you will notice that the previous commit has gone. The files have not been changed. The files have been changed, but it was not committed. You see that the code base is still here. Assume at any given time, you want to also remove these changes. You'll be able to right click the file and click on discard changes. I'm just going to do this on player interaction because this is a one-line change. If I click on discard changes here, you'll see that player interaction was like this. If I click on discard changes for player interaction, it says that you want to discard all changes and then just click on discard. Don't care. Now, as I go back to my Visual Studio, the line has been reverted. So I went back to a state before this file is changed. Okay, I will still be able to undo it, but it is what it is. So this is the atomicity of Git. You'll be able to make changes. You'll be able to revert to a previous state where the change has not been made. And you will also be able to discard these changes. So let's just commit this so that we show this up on the history. Fix bug. Okay. Now you have a working repository. Say you want to start collaborating with people. You will be able to click on this publish repository button, where you can give this repository a name, give it a description, and you can select if you want to keep this code private or not. For now, I'll put to keep this code private. And as I click on publish repository, you will see that you get a network activity. That's fine. You'll see that this starts spinning. This signifies that it is uploading to the remote repository that we have. So once you've uploaded it, you'll be able to, you see that this changed to fetch origin. So origin is the remote repository, the name of the remote repository. It's a alias that we give it so that we know that which repository we are on. You can set multiple remotes, but usually that is not very common. So you'll be able to fetch it. For example, if anyone else made changes to your code base, say you're in a collaboration, if they made changes and this change is not present in your current code base, you can fetch it like this. It's going to see if there are any changes and tells you whether or not you need to pull the changes, whether or not you need to just update your current code base with whatever is latest on the remote. That is not really important for now. So now that this is online, where do I find it? If you go to your own Discord, your own GitHub, you will be able to see this new repository with the name that you're given it in your repository list. It tells you that it is currently private. So if I try to visit this, say from an incognito tab, an incognito tab here, a private window, no one would be able to see it. It tells you it's 404. Okay. So how do you make it public? It's either when you push it, you make it public by unticking the make this code private tick box, or you go to the repository settings and you scroll all the way down to the bottom in the general settings here. And then in danger zone, you change the visibility of your repository to public. And it's gonna ask you if you want to make it, just do it. And then a bunch of all these terms of conditions, just do it. And then I have 2FA, so I need, okay. So once you've made this public, okay, once you make this public, if I go on this private tab again and I reload, you will see that this code base is now visible. You'll be able to add other people to your GitHub repository in collaborators, or make it such that only certain people can be can commit changes to this repository. But for now, okay, you're going to need this if you need collaborators, for people that can commit to your code base. So the way how you do it is you just click on add people and type in their GitHub username or their GitHub email and just select it from the list. Then you will be able to set them as a collaborator as they accept it. This is not important for now, but it will be if you're participating in game jams or in game projects that requires collaboration, which is most likely going to be level 1 games. And we'll be having level 1 games starting next week. So if you're interested in making your own game project, you can come down around and there'll be a team forming session as well. Okay, we'll talk about this later. So now that this repository is public, I can make more changes to it. Right. So assume now I want to work on a completely different feature. Okay, I want to work on a completely different feature in my code base. For example, okay, I'm not gonna go through like a very strong example here, but say I just want to make a new change or make a new feature to this code base. But I don't want to impact whatever that I have on this current branch, on my main branch. So what I can do is to use branching. And we usually call this a tree. So basically, you can think of your Git commits as a tree. And this is your main branch. So every other changes that you make, if you don't want it to impact your main branch, you'll be able to do it on a completely isolated branch that we call it branch. Yeah, you can name this branch anything else that you'd like it to. And then once you're done with it, you can then merge it back. You will be able to merge it back to your main branch for these changes to take effect to your main code base. And this will be very useful when you're collaborating with a lot of people, because it ensures that you always have a version of a code that is working on the main branch. So how do you do this in GitHub Desktop? If you click on this current branch drop down here, you see that there is a new branch that you can click on. So you'll be able to select this new branch and give it a name. I'm just going to call this new feature with a hyphen in the middle and click on create branch. Then we'll see that this branch called new feature has been created. And that's good. So any changes that I make to this new feature branch will be completely isolated of the main branch. How so? For example, now, if I go into player movement and I add a new line of comment here, okay, I'm just going to call it big change here, is a placeholder change. You'll see that this already shows up in the changes. So I'll be able to commit this like how I did previously. I can commit this and I just click on commit to new feature. And now you'll see that this new feature has been committed. Say I want to stop working on this new feature and I just want to get back to my main branch to see if there's anything that I need to fix. I'll be able to do so by clicking on this current branch and then just click on main branch. And you see that it says switching. So it will switch from the previous branch to the main branch, from the new feature branch to the main branch. And now you'll notice that the history is gone. If I go back to Visual Studio, the change is gone as well. So notice that the branches are all isolated of each other. And you'll be able to do a lot of changes on this isolated branch without impacting the work that you have done on the main branch. And it will not cause any kind of issues with maybe your code base breaking, because you always have a main branch that is working properly. Okay. So let's get back to our new feature here. So assume now, after I finish making this new feature, I just want to push this feature back in to my main branch. I've tested it enough and I've made sure that it is a working copy. So now I need this feature to also be in the main branch, in my main code base. Then you can work with something called git merge, which basically adds all the changes from any branch to any other branch. Okay. But there are some problems that may arise if multiple people are working on the same files on their own branches. We'll go through this later, and this is called merge conflict, and I'll show you how you can resolve it properly. So now that I'm on my new feature branch, it says big change here. I don't know if this is a big change or not, but I would say that this branch is ready to be merged. So now I will need to check out to our main branch. And then in GitHub Desktop, I'll have to click on this branch again and then click on choose a branch to merge into main. And here, I will be able to select the new feature branch. And it tells you that this will merge one commit from new feature to main with a check mark. This means there are no merge conflicts and this is safe to be merged. And here, it will say create a merge commit, squash a merge, or rebase. This depends on your workflow, but generally you would just create a merge commit. And once you click this, it tells you that successfully merged new feature into main. And if you go to history, you would see this big change maybe in your branch, in your main branch. So notice now your fetch currently becomes push. And this is because there are changes that has been done locally, but is not updated on your remote repository. The general rule of thumb is that once the local branch is stable, you want to push it to a remote repository to ensure that you always have a remote backup. So let's do this very quickly. I'm just going to click on push origin. But before that, let us get to our GitHub repository. And I'm just going to show you that now we have two commits. The final commit is fixed enemy die bug on GitHub. If I click on push origin now, which takes a while, if I go back to GitHub and I refresh, you see that now my latest commit is big change maybe, which is 4 minutes ago. So if you don't push the branch, the changes will not be recorded to your remote repository, which is why you should try to push whenever it is necessary, which is when your main branch has changes to it that you think should be saved a copy on the remote just in case something went wrong. Okay. So now that we've covered merge, what is merge conflict then? So a merge conflict is something similar to this. It's when Git could not resolve the changes to a particular file or multiple files when you're trying to merge two branches. And this will usually only happen when the same file is edited on different branches and is committed separately. Because they're both on two isolated environments, you will be able to make the changes on their own branch. But when you're trying to merge it, there will be a conflict because the files will be different and Git will not know how to resolve these differences. So this is a very quick image example, is that if you start off hello world, you create a branch and the main you change it to hello dog, and here you change it to hello cat, then it doesn't know which to take. Git doesn't know if you want to keep the hello dog version or you want to keep the hello cat version. Okay? So let us try to demonstrate this happening. We're going to go back to our code base. And here, I am going to be on the main branch. Okay? And then at the end of this jump, I'm going to say, I'm going to add a new line. It's like, there might be a merge conflict here. Okay. So I added this line. Now I'm going to commit this called merge conflict demo. I'm going to commit this change to me. If I go back to my new feature branch now, notice that there might be a merge conflict here has been removed because this was committed on main, and the other branch and the new feature branch is isolated from main. So this change will not be carried over. So if now at line 67, I add a new command called I will make this a merge conflict. And then I commit this. I commit this to the new feature branch. Okay. If I go back to my main branch now, and then I click choose a branch to merge into main, notice that now both the branches have a different line 67. Git doesn't know which one to take. So this will result in a merge conflict. It shows up as this red exclamation mark, and it tells you that there will be one conflicted file when merging new feature into main. We still need to merge it because we need to make the changes. So we need to have a way to resolve this properly. Let's just click on create a merge commit, but it will tell you that there are conflicts that occurred. It tells you to resolve conflicts before merge. So there are 3 strategies to resolve this conflict. Okay, the first one, if you click on this drop down here, is use the modified file from main. This means you will discard all the changes that was from the new feature branch, and you will use solely the changes that is on the main branch, which in this case will be whatever I wrote in the main branch in the comments. Or you can choose to use the modified file from new feature, which does the same thing, but it takes the changes from new feature instead of main, and then discard all the features from main instead of new feature. So this will be okay to use if you have a definitive view that one file is correct and the other is wrong. Then you'll be able to select the file from the correct branch to merge it into it. But there are certain times where when you're working to collaborate with other people, you'll be editing the same script, but you'll be adding 2 different functionalities. And you want both functionalities to be in this new script that you have merged. So what you can do is you click open in Visual Studio Code, or even better, you just need to go to your Visual Studio. It's going to tell you that file contains merge conflict. And this is how it signifies the merge conflict. Okay. So I'm just going to very quickly click close this so that I'll be able to resolve this in Visual Studio. You just close this window, don't click on abort. Now, as I go into Visual Studio, it tells me that there's a merge conflict. So what do these symbols mean? This symbol with the left arrow and says head is the current branch that I am on. So these are the changes from the current branch that I am on. Whereas this, where it says I will make this a merge conflict, and then it tells you that this is incoming from a new feature, from the new feature branch. It's separated by this separator to tell you that this part is from my current branch, which is mean, and this part is from the new feature branch, which is why I've deliberately made it to have a merge conflict. So you can click on Open Merge Editor at the top here. And this will give you a very nice view of what this looks like. Okay. So there is the incoming, which is from new feature. There's the current, which is main on the right-hand side. And then there's the result at the bottom here. So you will be able to select which file or which lines from which commits that you want. In this case, I can click on any of these lines, and you will I can click on this checkbox, and you will see that in result this shows up. If I don't, in result it's empty. And I can select both sides. Right, I can select both sides, and this will tell you that how this result looks like. Okay. If I select one over the other first, it will be on top. If I select the second one, so the second one will always be at the bottom. The first one will always be on top. Right. Okay. What did I click? Okay, so I will go to inline mode, side-by-side mode. I clicked something wrong there. Where did I turn on the diff view? Okay, so now I will be able to take all of these both together. And then if I click on, where is it? Accept merge, this will make this result file as the final file that you want after you resolve this merge conflict. So if I click on accept merge here, you'll see both lines appear, and in GitHub Desktop, there are no more merge conflicts. It tells you that all conflicts have resolved when you click on that notification. Then you can just click on continue merge, and this will merge it. Okay, so this is how you can resolve a merge conflict. Some merge conflicts can be way more, I mean, most of the merge conflicts that you're going to encounter will be way more complicated than what I did just now, but you had the gist of ideas of how you can resolve it. Okay. So that is a merge conflict, and we resolved it. Okay. But what is even better than resolving merge conflicts when they happen is to avoid them like a plague. Because obviously it is not easy to resolve merge conflicts. As you can see, you need to see what changes you want and select them. Okay, so you probably want to avoid them as much as possible unless it is necessary for this merge conflict to happen. It feels like an accident most of the time, but the majority of the time you can definitely avoid it. So the way to avoid this is to ensure that only certain people modify certain files, and that the files are only changes in certain branches. and that there are no two people working on the same files of the same name in the same directory at the same time. So definitely, if you do that, where one person only work on one file at the same time, and that file is only for them to work on, you will not have this problem. But most importantly is to ensure that communication is good so that other team members in your team know that who is working on this and that they shouldn't work on this file until that other person has completed it and then the changes have been pulled into their own branch. There are times where this is unavoidable if you're trying to rush a deadline. So try to be careful anyways to ensure that you don't work on this merge conflict thing. Okay, so let's take a very short break here. Before we build our game. And I say a short break, but generally speaking, this is the perfect time for you to visit itch.io. So itch.io is a platform that allows you to share indie games. And there's a bunch of indie games on there that you can try out. But most importantly, I want you all to register an account on itch.io if you haven't already, because we'll be using itch.io for our stuff later. Okay, so let me just very quickly stop share so that you don't see my login password. Freeze this also. There's also an authentication code. Okay. 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 Let me unfreeze. Okay. So can you share the screen again so you can see this? Okay, so now our tutorial game is almost completed. You have gone through how you can do version control. You've gone through the basics of Unity. You've gone through basics programming part and everything. So understandably so, you probably want to build your game so that other people can play it. Right. So what you can do is that you first, okay, will need to choose a platform to build on. And the good thing about Unity is that you can choose which platform to build to with a single click. You can choose it with a single click. It's that simple. Okay. And 95% of the time it's going to work. The 5% of the time that it doesn't work is usually some platform specific issues that require you to debug. But if you do encounter it in any case, you probably should have some idea on how you can debug it and try to make it work. So let's try to see what we can do with this. But first of all, given that we have this very bare bone game here, if we try to publish it, there's no menu. People don't know how they can start the game. So we should probably start with a very simple UI screen or a start screen first. I'm going to click on create, and we're going to create a new scene, which is called the start scene. And then double click on it so that I'll be able to edit it. So as what we have previously taught in, I believe, week 2, how we can use the basic UI system from Unity. We're just going to create a very simple UI here with 2 buttons. The first one is start. No, with 1 button, which is just the start button. Okay. So I'm going to right click here and create a UI button, Text Mesh Pro. And I'm just going to rename this as start button. And you'll see that it's in the bottom left. I don't want this to be on the bottom left. So let's just move this around to the middle of the screen. Before that, make sure that you go to Canvas and then change the UI scale mode to scale with screen size. And give this a resolution reference resolution of 1920 by 1080. This allows your UI to scale with the screen sizes and works on devices with different screen sizes and screen resolutions. It's always a nice to have to make sure that these kinds of things are working properly. Then you're just going to go to start button and you just move it to the very center here, like 0, 0. Okay. And then I'm just going to make this button a lot wider and a lot taller. Maybe a bit more. Okay, something like this, right? And then we're going to drop down the button and go to text and then change this text in the button to start game. Then we can change the size to something bigger, like 80 maybe. Okay. So once you have done the button, as of this point, you should know that we are going to need a script. So I'm just going to create an empty object, and then I'm just going to call this the start screen, start menu manager. Okay. And then we're going to go to the scripts folder to create a C# script called the start menu manager. And then double click on it. There's nothing else that we need in this script. We can remove all the Unity methods and then add a public void method called start game, which debug.log starts game. And then all it does is do a scene manager dot load scene. And then we're just going to load the scene index 1. This will be our main game scene. Okay. So we load the scene 1. And as I have already mentioned previously, you need every scene that you want to include in your game to be in the build settings here. So just go to File, Build Settings, and then go to Scene folder and drag the start scene in. Then you drag it to the very start so that this becomes start, sample, end. Okay, now notice that sample scene now has a build index of 1. Start scene has a build index of 0. This is exactly how we want this to be. So I will click on play. And then now if I click on this button, nothing happens. So the reason is because we haven't hooked this button up to the script. So we want to first attach this start menu manager to the start menu manager game object. Attach the script to here. Then go to the button and scroll down to the button component where it has an on click. You click on this, add to the list, and then you drag the start menu manager in here, and then select start menu manager, start game. You drag it into this here. Did you define it as a public?
Yes.
Okay, did you attach the script to start menu manager?
Yes.
Yes. Do you see the
No.
no? Take a look.
Oh,
Yeah, you forgot to add. Save the script, and this should compile properly, and you'll be able to see it. Okay, so now if I click on start game now, you will see that I go to the first scene as intended. And me dying is still working properly. But, okay. So I'm gonna go back here to change the movement speed so that I'll be able to clear the game properly. Okay. Now you also want to go to the end scene. You also want to go to the end scene. And as well, once you end the game, you want to have a way for the probably a way for the player to restart it. So we're gonna do the same thing. You're gonna right click as the start scene. You're gonna right click and add a button. And then we call this the restart button. And then I'll just go to canvas again, change the scaler to scale with screen size, change the resolution to 1920 by 1080. Okay. And then go to the button and then position it to the middle of the screen. And then change the values of the width and the height. Then I go to the text component and change this to restart game and increase the font size. Okay. All right. So now we're also going to create an empty, which is going to be called the menu manager. And notice that what we want to do with this restart game is exactly the same as what we did for the start game. We just want to load the first stage again. So what you can do is to just add the start menu manager back into this menu manager and go to restart button and go to on click, drag the menu manager in, and then select the start game from start menu manager again. Basically, the restart game is going to be the same as start game. So it's just going to be two scenes that look exactly the same, but with a different name. Okay. So now as I press play, I click on start game, the game starts. Okay, and then as I clear the stage, I can click on restart game, which brings me back to the same stage again. Okay, that looks pretty good. Okay, now we have a way to start the game and we have a way to end the game. We will be able to build the game for others to try it out. So I'll go to File. Is there any problem?
Sorry, let's stop the game. This is not showing the start scene. Wait. Because I just I selected the end scene, then it just only show me.
Okay, so it will show you the scene that you last left.
Yes.
Before you press play, right?
Yes.
That's normal behavior.
Oh,
okay. That's normal behavior. Okay. Yeah, nothing much to be scared about there. Right. So now we have a start scene, we have a game scene, we have an end scene. The game is fully functional. We can publish it. So now you go to File, Build Settings, and you can select the different platforms to build on. So I remember that I did mention to download the WebGL support at the very start of this tutorial. So we'll be using WebGL because WebGL games can be played directly in the browser. So I'll select the WebGL here in Build Settings and click on Switch Platform. This will take a while depending on your PC's specs. Usually the switching process takes about 5 minutes for the first switch. And for subsequent switches, it will be much faster. But that depends on your PC. So I think, yeah. So while this is switching, I'll just explain what is WebGL. So WebGL is a browser-based platform. It stands for the Web Graphics Library, but that's not really important. And basically, since it is browser-based, it will be OS agnostic. You will be able to play the game on any OS as long as it supports it. You can play it on your Windows laptop, you can play it on your MacBook, you can play it on a Linux platform. As long as it has a browser, you can play it, even on mobile devices, but support may vary. And experience may vary too, because some games only supports keyboard input, for example, our platformer here. But in theory, if you can connect a keyboard to your phone, you will be able to play it on your phone as well. That's in theory. And it is just a very powerful platform because as long as you have browser, you can play it. And the downside is that it is a little bit less performant than platform native, such as a Windows build or a Mac build. But I would say this is acceptable. This is some acceptable drawbacks for its language agnostic, for its OS agnostic support. You can host it on websites such as itch.io, or you can create your own hosting service with a backend server and a front-end web page. But we'll be using itch.io as a showcase today because it's much easier and it's free to use as well. And it's also the go-to for a lot of indie developers. WebGL will take much longer to build because the compilation process, the compilation pipeline is a lot more complicated than building directly on Windows or Mac, for example. But this is not really a problem. So now that the platform has switched over properly, it tells you that you can do texture compression, don't care. You can take development build, don't care. I'm just gonna click on code optimization And notice that there's several different options here. So I believe in Unity 2022, some of these options are bugged and they take infinite amount of time to compile. So for sanity's sake, typically for now, you want to always select shorter build time just to avoid running into the bugs. I think that there was already some mentions on fixing it, but I don't know if this has been fixed. I don't know if I have the fixed version on my PC as well. So I'll just select shorter build time here, just to ensure that I don't run into any problems. Then you can just click on build. So once you click on build, it's going to ask you for a folder. So this folder is where your build game is going to be in. And I'm just going to put this in my own Unity projects folder here. And I'm just going to call this GameStart 2024. And then as a WebGL subfolder. You can put it anywhere you like as long as it is in its own folder and the folder is empty, because it's going to create several files and it will be very difficult for you to find where the files are if you put it in a non-empty folder. Okay, just make sure you keep your stuff organized. So once you click on select folder, it's going to start compile. It's going to start the compilation process, which usually takes a while. But since I selected shorter build time, I believe this will take about a minute on my PC. So for this time, we're just going to wait. Yes. Okay, so there are three major builds that you can select. There's faster build time, which makes it faster to build. There's faster runtime, which optimizes the final build code such that it will run a little bit faster, marginally, I think about 8 to 15% faster than shorter build time. And there's also smaller file size. That one is to compress the stuff that you send out as much as possible without impacting too much in terms of performance. So if you make a very big game, but it's not very it's not really resource intensive, it's just very space intensive, then you probably want to select smaller file size to make sure that your server is not overloaded by a bunch of files that it needs to send out. The files also impact your loading times because you need to fetch all the assets when you're playing on the browser. But yeah, so yeah, it's best you select faster runtime for this, for that case. Faster runtime speed. Yeah, faster runtime speed in that case. Because you want to make sure that the performance is not impacted. But usually when it comes to 2D games, this will not be a problem. And when it comes to 3D games, it's very rare for people to use WebGL because of its performance downsides and just its overall capability to render 3D games in general. This takes a while. I wonder if there's anything else. Okay, I'm just gonna going to introduce the website itch.io. It's a video game platform for indie developers, and then you can create or publish your games on itch. This is my creator dashboard. There are several games that I put up here. There's also the GameStart 2023 for the workshop that I handled last year. It gives you a summary of how many downloads you got, right? And it also gives you a summary of how many people viewed your games and everything. So if you click on browse, you can see that all the different games that people have made. There's like so many games on this platform. Most of these are indie games. So yeah, if you just want to find some indie games to play around, this is the go-to platform because the creators basically live on donations. So there's no platform fees, unlike Steam or Epic Games, where there are platform fees when you publish your games on them. The games here, the service is completely free. Itch is not going to take any kind of platform fee from you, and all the donations that you make is going to go directly into the creator's pocket. So this is a good place to support indie developers if you want to. But aside from that, it's also a good place for us to put our own games up because we're technically also considered as indie developers. Okay, this is about to finish. 5 minutes is the normal time, I would say. Okay, so now this is finished. You will see that I have a WebGL folder with build template data index.html inside. You'll notice that if you double click on index.html, it actually doesn't run because you're going to need a server to serve all the files, serve all the assets that you have in your game. But that is barely important. So to publish the game, all you do is you go to your itch.io dashboard and you click on this drop down and select upload new project. Here it tells you that I don't have any payment configured. So I'm just going to click on no payment at the pricing there. Give it any title. Okay. Give it anything. And then if we're building on WebGL, you want to select the kind of project to be HTML. It tells you have a zip or HTML file that will be played in the browser. Then here, I'm just going to change the release status prototype just for so that I will be able to delete in the future. Then in WebGL, for the folder that we have just created for the WebGL build, right click, and then you want to compress it. You can compress it any way you want. I'm going to use 7-zip here. You compress it to a zip file. Then here in uploads, you want to click on upload file. And then go all the way back to where you put the folder at and click on webgl.zip. So this zip file should have an index.html file inside of it. And I believe this should work properly. Yes. Okay. Then you will just click on this file will be played in the browser. This file will be played in the browser. If it is an executable, you will be able to click on any of this platform to signify which platform this executable support so that it will be able to tag the game appropriately. But for now, we're just going to click on this file will be played in the browser so that we can play the game properly. Then here, there's the embed options. This is only available if the game is playable on the PC, on the browser. So it tells you it checks if you can manually set size or auto detect. For simplicity's sake, I'm just going to click on manually set size because auto detect doesn't work all the time. And it tells you it works for Unity HTML, but it doesn't really. Sometimes it just doesn't work. So just put manually set size and then give this like 1280 by 720, which is 720p. Okay. Then there are frame options. You can select if this is mobile friendly. Obviously, this is not mobile friendly. You can select if you want to automatically start on page load, but this is really, really not recommended for Unity games because the loading is very, very resource heavy. So you want to untick this. Okay, make sure you untick this. If not, it's going to lag the browser and potentially crash it when you try to open this web page. Then, full screen button. You can have the full screen button, But generally speaking, Unity WebGL should already come with a full screen button. So you don't need this. And then another stuff of this, you don't really need to care about it. Add any description that you want. Okay. Select any genre that you want. Like a platformer game. And then the community, you can add a discussion board. You can click it to be comments only. And then now, finally, you will be able to save it as a draft, save it as restricted, or after you saved it, you can change this to a public. So if you put public, this means anyone will be able to see your game that you post on h.io. If you put it as a draft, it will tell you that only those who can edit the project can view, restricted only owners and everything. So for now, I'm just going to save this as a draft. And then as I save this, you will see that it tells you loading the game for the first time. Then the run game button shows up. As I click on it, the classic Unity logo with the loading, the classic Unity splash screen, and you can see that the start game is here. As I click on it, notice that the game is running properly. And I can still restart it as well. The problems, me dying. Okay, jumping on enemies, killing them. Trying to solve all the puzzles before I leave and everything. Right. All of these are working. So as you see this now, congratulations, you have published your first ever video game. If this is your first ever video game.
I think
Yes, so these are the files for the web job.
So then I just have to make
This is the zip list.
Oh, okay. Would it be safe for me to
Yes, it is fine. As long as the file inside is not shared. Okay, I forgot to change this date again. It's 14th. Okay. So this is itch.io and this is WebGL. And of course, you will also be able to build it into different platforms. And Unity allows you to switch to all of these different platforms as long as you have installed their SDK with one click. Windows, Mac, Linux. Okay, if I click on switch platform back again, I can build a Windows game as is. And then this is going to be much faster than building the WebGL game because the compilation pipeline is much simpler. They can change the architecture to support only 64-bit or support 32-bit as well. And if you're on Mac, you'll be able to build on Mac. Only Mac can build on Mac because Apple is an insecure platform. And then if you're on Linux, you can also build to Linux. If you just need to install the Linux SDK to build on Linux. As you can see, there are also so many different support. There's Android, there's iOS, PS4, PS5, the Universal Windows platform, which is for Xbox, as well as Microsoft's HoloLens, so that their XR platform. There's tvOS, you can build to any kind of Android TV, as well as Vision OS, you can build onto the $3,500 headset that lets you live in the future. So as you can see, all of these, you can change to these build support with one click, and you can build and it works 95% of the time. To show you that I'm not coping, I'll build onto Windows right now. And I'm just going to build it to the same location as I did just now. Okay, put it in a different folder. And you can see that this is extremely fast. This probably takes less than a minute to build, generally speaking. Okay, it's done. So the Windows build has more files than the web build. And generally speaking, for the Windows build, you also want to delete this folder. It's called the do not ship folder. There's a suffix here, do not ship. Delete it. Okay, you don't need it. And never ship this because it allows other people to reverse engineer your game. Well, it's not that difficult to reverse engineer in the first place. Okay.
Without using the HTML, the GameStart,
Mm-hmm. You just pick this game.
No.
You need to change this.
Yeah, I didn't change.
Oh, you can't pick it as 7-zip. It needs to be a zip.
Oh,
It cannot be a 7-zip file. Because platform doesn't support 7-zip. Frankly speaking. Okay, so once you're done with this, you can click on GameStart tutorial, which is the Windows exe. Double click on it. Takes a while to load, but once it loads, it says made with Unity, and this is also playable on Windows. Not too much difference, except for me dying. Okay, but you get the gist. Yeah. So yeah, very easy build support because Unity is the better platform to build for multiple platforms.
Oh, okay.
All right, so with this marks the end of this workshop. And before we end, another round of publicity for our week 5 game jam, which we will be holding this Saturday, 14th September. It will be 12 p.m. I believe in this classroom as well, in the Unity workshop classroom. And the themes will be announced on that day. Dinners will be provided. And if you are planning to come to week 5 game jam, please make sure you bring a stationery of your choice. A stationery of your choice. Yes. So you can refer to our previous publicity post on the week 5 game jam. Okay. And as well as the level 1 games, which will be starting next week. And this will continue on until the rest of the semester. Until the end of the semester, for the rest of the semester, starting next week. Next week will be your brainstorm day, where you can work with other game developers, designers, or artists, or anything to start brainstorming an idea, as well as to create your own game from scratch until the rest of the semester. So if you're interested in picking game development up as a hobby, or if you're interested in just continuing game development as a career, maybe in the future, be sure to come around so that we can start so that you can start making your own game and have a feel of how it feels like to be an actual game developer working in a group. Okay, any questions? No questions. Any questions for the people online? Let's wait for a while. And if you don't have any questions, you can leave now. This is the end of the workshop, and thank you for coming. And for the people that haven't taken attendance, this is the attendance QR code.